Hello, and welcome to Green Dragon, a monthly show where we talk about green initiatives in Maryland and Howard County, ongoing sustainability efforts at Howard Community College, and ideas and ways for you to be more sustainable at home. I'm Bob Marietta, HCC's Environmental Health and Safety Supervisor, and I thank you for watching today. My guest today is Professor Russell Dickerson, whose research focuses on the multidisciplinary areas of atmospheric chemistry, air pollution, greenhouse gases, and environmental justice. So, Professor, I know from your bio that you are involved in climate research with many national and international scientific organizations. So, how and why did you end up here in Maryland?
Well, the simple answer is they offered me a good job after I was a postdoc. I thought it would be fun to be an assistant professor, and Maryland sounded like a nice place to live. So it must have worked because I've been here 40 years.
Whoa. Okay. Yeah, we like to think it's a nice place to live too. Now, if any of our students wanted to pursue climate studies, what should they start out by studying?
Well, while they're at your community college, it's essential that they get some of the basics of hard science, mathematics, calculus, basic physics and chemistry, some basic biology. Then there are many paths to understanding how the atmosphere and oceans work. There are biological approaches to it. There are fluid dynamics, like the flow in the atmosphere. The path I took was through chemistry to understand air pollutants and the trace gases and particles in the atmosphere that can change air quality and can interact with the climate.
Well, this is going to sound like a really simple question, but what does climate change have to do with our weather?
No, it's not simple questions are the best, and it's certainly not a foolish question. The difference between weather and climate is, well, first let me say what it's not. Climate is not the average weather. So the weather we have today, the weather we have tomorrow, they all make up climate. But the climate of Maryland is, for example, that we get a lot of rain in every month. So it's a very green place, that we have hot summers, mild winters, for example. On any given day, that's the weather. So if the climate changes, then you could expect some change in the weather, but only statistically, not on any given day. So as the Earth gets warmer due to more greenhouse gases in the atmosphere, we can expect more warm weather, but that could be higher maximum temperatures. More likely it will be that summer begins earlier and ends later, and winters are a little softer than they used to be. So people sometimes say climate is the average weather, but that's not right, because imagine we get 3 inches of rain a month. And we got 3 inches of rain just yesterday in a big storm. But we could continue to get 3 inches of rain a month on average, but it could come all at once, and that would be a change in climate. That would not be a very favorable change in climate. We like the rain to fall gently and frequently. That's good for the farmers, good for the trees, good for your garden. So just the average doesn't necessarily tell you what the climate's like.
Okay. So that being said, okay, how come the Canadian wildfires had such a big impact on our air quality this year?
Well, that's a really fascinating new development. So let me start off by saying that what air quality is. That's the composition of the atmosphere. Are there pollutants in the atmosphere that make people sick or even kill people? And it's still a major problem, but we've made huge progress over the past few decades. The quality of the atmosphere is many times better than it was a few decades ago. And the reason for that is cars are cleaner. The engineers have done a nice job. 90% or more of the pollutants that would ordinarily come out of the tailpipe of your car are converted into something harmless before they come out. Power plants have been cleaned up, or in the case of a lot of coal-fired power plants, replaced with natural gas that burns cleaner. So the quality of the air we breathe is much nicer, much cleaner, healthier than it used to be. Unfortunately, some of the other pollutants like carbon dioxide and methane, we have not controlled. These are long-lived pollutants that absorb infrared radiation, and they warm the planet on average. They change the climate. And as it's become warmer in the far northern reaches like Canada, it's become drier. And they've had massive forest fires this summer. And this may be the new normal, that there are more trees burning, more acreage burning in the far north. And the weather patterns have brought that to us. So although we've done a really good job controlling fossil fuel emissions and our local pollution sources, the boreal forest fires, the forest fires in the far northern parts of Canada and in Siberia as well, have gotten much worse, and they will probably continue to do so unless we do something to correct the climate.
So boycotting maple syrup is not going to get us anywhere.
I wouldn't recommend that. That's wonderful stuff. But the only way to fix it, we could work harder on being able to put out the fires. But because it's drier, windier, and warmer, that's a good recipe for initiating forest fires. And when the winds are right, they carry that smoke to us, and that smoke is indeed dangerous. It contains toxins, carbon monoxide, black and brown carbon, soot, oxides of nitrogen, the stuff that can make Los Angeles type smog, as well as fine particles that interfere with respiration and are linked to cardiovascular health problems. So things like heart attack and stroke can be exacerbated by such air pollutants from forest fires.
No. So which pollutants would you say had the biggest impact on our health?
Well, it's probably the fine particulate matter. We usually cut pollutants into those that are solid or liquids, little droplets or specks of things that float around in the atmosphere, and the others are gases. And they're both important. The gases, the most important one is probably ozone and related species. Before I talk about ozone too much, I should say that NASA likes the saying, it's good up there and bad down here. So we want to protect the ozone layer. That's up 25 kilometers, so 15 miles above the Earth's surface, and it protects us from dangerous ultraviolet radiation. So we want to protect that ozone layer and keep it up there, but you don't want to breathe it. So ozone down here causes premature aging of the lungs and other respiratory problems. And we call that Los Angeles type smog because that's where it was first recognized. And it's a function of lots of sunshine and car exhaust. And they make the kind of smog that burns your eyes and makes it hard to breathe. And this has morbidity and mortality, meaning it makes people sick, or can even kill them. But the fine particles in the atmosphere are probably worse. And maybe the worst of all, it's hard to say which are the worst culprits, but soot, the black stuff that comes out of big diesel trucks that haven't been maintained properly. This is a group 1 carcinogen, and it's been linked to asthma, inhibited cognitive development in children, and respiratory problems.
So what do we mean when we talk about air quality? And what do these short-lived pollutants you mentioned, how do they affect that?
Okay, usually when we talk about air quality, we are talking about the species that are toxic, but only hang around in the atmosphere for a few weeks or even a few hours. They contribute less to climate change than the long-lived species, but they tend to be more toxic. Methane and carbon dioxide are not particularly dangerous to breathe, but they do have a major impact on the Earth's climate. So when we talk about air quality, we talk about your ability to see, how far can you see, how hazy is it, and how well can you breathe. And so the immediate effect is on your lungs and your eyes. And so generally when we talk about air quality, we're talking about ozone or fine particulate matter. There used to be things like lead and carbon monoxide, but those have been fixed and they haven't been a problem in Maryland for years. Maryland does have some serious problems. We, especially after this summer with all those forest fires, we are probably going to be what's called non-attainment, which means we're in violation of the ambient air quality standards for ozone. That is a big problem. We were nearly finished with that issue. Maryland was doing really well. We were just about to get the seal of approval from EPA. And then all these big forest fires clobbered us this year. So we had a dozen or so days of bad air quality that were a threat to people's health. So now we may have to start over and figure out how are we going to fix this problem that originated outside Maryland.
So what impact does where we live have on air quality?
Oh, that's another really good question. Well, we're on the Eastern Seaboard, and so here in Maryland, we have Washington, D.C. to the south, and we have Philadelphia and New York to the north, and the air goes back and forth. It's usually air from Washington blowing to us, so we get their air pollution, but we give ours to Philly, and that goes on to New York. Also, we are generally downwind of a lot of power plants along the Ohio River Valley. That's the Ohio River Valley. And they used to burn a lot of coal in an uncontrolled way. That has been, to a large extent, cleaned up. That had to go to court. In fact, went to the Supreme Court eventually, and they made a ruling that interstate transport of air pollution was not legal, and so it's been cleaned up substantially. The other interesting thing, what makes Maryland interesting is, in large part, the Chesapeake Bay. And so the bay can change the local weather. It's usually cooler than the land. And so there can be what we call a bay breeze. It's like a sea breeze on a hot summer day. The air near the surface of the land gets hotter than the air over the water, and it rises, forms clouds. And that sucks the air in at low altitudes, and so the air can come in off of the bay. And that bay breeze can recirculate pollutants, and that gives us an unusual climate, small-scale climate, urban-scale climate, that can contribute to our air quality problems.
How about between neighborhoods? What's the air quality like from, one neighborhood to the next, downtown to the suburbs?
Oh, that's a really good question. That's a question of environmental justice. A lot of the pollutants actually for which we're in the biggest trouble, ozone and fine particulate matter as a whole, these are produced in the atmosphere and fairly uniformly distributed on scales of 100 miles or so. So one neighborhood's going to look like another for those pollutants. But that's not necessarily where the action is. There's some very recent research that points to the neighborhood scale, and things like emissions of dust and diesel truck emissions can be very different. We did a nice experiment in Baltimore, driving up one avenue and down another, and these were only separated by about 150 yards, these two avenues, but there was a factor of 3 difference in the soot, in the black carbon. And that's because there were a lot of trucks on both avenues, but one of them had a lot of stop and go traffic. And your experience tells you when you're out on the Beltway or I-95, a big diesel truck moving along at speed doesn't usually emit too much black carbon. But if you have a traffic jam and there's stop and go, you can see the black stuff come out of the stacks. And that's because when they start to accelerate, they run rich for a while. And it's a new problem for the engineers to solve. So indeed, one neighborhood can have substantially more fine particulate matter, especially these primary pollutants like soot, than another neighborhood. And that's a big challenge for scientists, for engineers, and for policymakers. We have to find where are those neighborhoods, what's causing it. and then try to get in there and fix it. And there are probably hundreds of these neighborhoods. We found a few, but we're still looking. I don't know if there are any in Howard County.
It,
Probably,
do you
probably
see
along I-95.
do you see any connection between the heat islands that people are beginning to work on and these heavier pollution areas?
Absolutely. Temperature and pollution are linked. Well, they both can adversely impact human health, but the hotter it is, the more black carbon comes out of diesel engines. We don't fully understand why yet. They tend to work a little bit better for other pollutants, but the hotter it is, the more emissions from diesel engines. And that Los Angeles type smog that I was talking about, that gets worse on hot days. You tend to have stagnant conditions on the hottest days. That's when it's sunny, the winds are weak. That's a bad day for air quality. And so the urban heat island effect means the neighborhoods that have the most emissions and often have the people that have the least access to healthcare are the most affected by poor air quality. So some of that you can fix. Trees are good for helping to fight the urban heat island effect.
Yeah, I was just going to ask, is these new campaigns to increase the tree canopy? Is that something we should be looking forward to?
Absolutely. It's expensive, but if you convert a parking lot into a park, you can cool the temperature by 10 degrees. It has a great benefit, a psychological benefit as well, but it certainly improves the local climate and air quality.
Yeah, you can see that. Okay, so if we're getting better in some parts of our air quality, because of changes we've made, to gasoline and aerosols and not burning coal, what's the next thing you think we should be concentrating on? What's our next step to get better?
Well, Maryland is required now to meet certain climate goals, and they're really very ambitious. We're basically in a few decades going to have to go off of fossil fuel altogether to be compliant with these new laws. So I think to meet the goals in about 12 years, half of the cars on Maryland highways, cars and trucks together, will have to be electric, have to be powered with batteries, and they will have to get their electricity from renewable sources. A lot of the coal-fired power plants have been switched over to natural gas, and that's great. It's cleaner. It has only half of the greenhouse forcing that coal does, but it's not a final solution. It's like a bridging technology. So we're going to have to go to wind, solar. I think nuclear has to be on the table. If you eliminate all fossil fuel combustion, you will eliminate most of the short-lived toxic pollutants that are a hazard to human health. And that will help slow down climate change. And hopefully that will help slow down the big forest fires that are occurring in the far north.
What role do you think mass transportation needs to have in order for us to meet these goals?
Oh, that's a great question. I'm a big fan of trains. I like trains. In fact, I'm going to try to take the MARC train up to Baltimore tomorrow from Riverdale, which is near where I live. If you put 100 people on a train as opposed to being in 100 cars, the total emissions are much, much less. So that sort of public transportation, buses, trains, rapid transit, these are excellent solutions. If they're powered by fossil fuel, you still have some problem, but it's a fraction of each individual climbing into a 3,000-pound car and driving him or herself to work every morning.
Now, it always seems like it's always gotten hot in the summer. So can you summarize what's different this year? Why are we so hot?
The planet is certainly hotter. If you're referring to the whole planet, then part of that is El Nino, and because we're going into an El Nino, that El Nino doesn't have too much effect on on Maryland specifically. But the increasing greenhouse gases have increased the planet as a whole. Why? I don't know if Maryland itself is headed for any records, but it's been a hot summer, and I think that's just part of the natural variability. We have gotten warmer, about the same as the global average. We're about mid-latitude, halfway between the equator and the poles, roughly, and so we've experienced about the average amount of climate change. The biggest effects are really at the poles, and that's something that the physics is easy to understand. So if the poles are covered in snow and ice, they're white, and they reflect all the sunshine back into space. If you melt all that snow and those icebergs and sea ice, you have open ocean. And from the standpoint of sunshine, the open ocean is black. It absorbs all of the radiation, all the sunshine that comes in. So you've gone from reflecting almost all of it back into space to absorbing almost all of it into the Earth's surface. And that's a positive feedback. So as you start getting rid of the ice, the ocean gets warmer, the ice melts faster, and on it goes until all of the polar ice is gone. And so the extreme north and south parts of the globe have heated the most.
When that ice goes, are you making any predictions as to what the sea level rise is going to be in the Chesapeake Bay?
There are a lot of predictions. We are already experiencing sea level rise in the Chesapeake Bay, and I think before the century's out, you will see serious sea level rise on the order of a yard, a meter. And that's going to be expensive for people and buildings that are close to the bay. I think that's unfortunately inevitable. If we stopped emitting greenhouse gases tomorrow, you would continue to see sea level rise, and we would have to take action to avoid increased flooding.
Yeah, I know Norfolk is already building huge seawalls, and they're talking about it in Annapolis. So we are beginning to get prepared in some areas.
Yeah, well, the Navy has taken great interest in climate change. Sailors in general really care about the weather. So when the climate changes, the weather changes with it, and we have to adapt.
Yeah. So what can individuals do? How can we, influence government policies and corporate investments that might help reduce our dependence on burning these fossil fuels?
Well, there are a lot of things you can do to reduce the dependence on fossil fuel, starting with small things. If you could ride a bike instead of drive to work, that's a good thing. That'll save a lot of fossil fuel emissions. You could try to buy your electricity from a renewable source. Some of the things are a little more expensive, like going to geothermal power in your house. It's probable that there will be policies to get us off of natural gas for heating over the next few decades. Heat pumps, this geothermal can work really well, but the upfront investment is pretty substantial. I think you have to encourage our local and federal government to divest from fossil fuels and look at alternatives. And population control has to be on the table. The planet is heading toward 8 billion people. And if 8 billion people have the lifestyle of the average American, the climate is pretty much doomed.
That sounds ominous. Okay. Now, how will climate change impact other things like agriculture? You mentioned transportation, but ocean currents and generally wildlife in general.
Well, those are really important topics that could take a long time to answer. So let me start by saying, to feed humanity, we have taken over much of the ecosystems, much of the soil on the planet, stripped the trees or the natural grass and planted crops on there. we don't really know all of the ramifications of turning wild lands into agricultural lands. We know some. They emit nitrous oxide, for example. That's N2O. It's a laughing gas, but it's not a laughing matter because it destroys ozone in the stratosphere, and it's a greenhouse gas. But we got to eat. So that's a hard problem to solve. The amount of wildlife out there shrinks as we reduce the virgin forest and burn tropical rainforests and take over more of the natural vegetation out there. Now, I have to confess that I eat meat. I like meat, but eating a vegetarian diet is easier on the planet. It takes 5, 10, 15 times as much nitrogen to put into chickens, pigs, or cattle to get the same amount of protein that you could get if you ate a plant-based diet. So at least in my house, we try to eat primarily plant-based diets, and that's a little easier on the environment.
We hear on some newscasts that people have been keeping track, and there have been periodically heat waves across the world. Is there anything different about this year? And is this really climate change that we're seeing in these statistics?
Any individual event cannot be attributed to climate change. But on average, the frequency at which you have these severe heat waves has increased and will continue to increase because of what we put into the atmosphere. Carbon dioxide, methane, and many other species, they are transparent to solar radiation. They let the sunshine come through and warm the surface, but they capture the infrared radiation when the Earth tries to emit back into space to cool itself off. It's trapped in ever increasing amounts by the greenhouse gases. And that continues to warm the Earth's surface. So it's playing the odds. It's playing roulette on a wheel that is rigged. You're going to lose more often.
Okay. Well, the college is recently undertaking a composting program where we collect all the food waste on campus.
It's great.
What impact will food waste have on our greenhouse gas levels?
Oh, that's great. That's something very specific you can do, and it's really beneficial. So if you just throw your garbage out and it goes into a landfill, the landfill is covered with soil, and all that garbage goes what we call anaerobic, means the oxygen disappears, and it begins to rot, and it makes methane. And that methane is a greenhouse forcing substance. So if we're lucky, all that methane can be collected and piped into generators, and we can help generate electricity with it. If we're not lucky, it just escapes into the atmosphere and contributes to global warming. So what about compost heaps? Well, they're much better than a landfill. They produce less methane, and when you're finished, you have that nice loamy fertilizer garden enhancing material that's you can use. You can dig into the soil and your tomatoes will grow better. So if the college is putting less into the landfill and more into your compost heaps, that's definitely a benefit for you locally, for the state, to help us meet our climate goals, and for the planet as a whole.
Well, if we manage to electrify everything by 2030, like our governor's talking about, what will the impact be on climate change? We know we're not going to, go back, but can we at least stop it from getting any worse?
Well, Maryland by itself can't do much. We're just a tiny state in a big world, but we can lead by example. I think we have a little longer than 2030 to go completely off of fossil fuels. But you're right, the governor has a very ambitious plan. And it's going to take a big effort from all of us to achieve that. We can improve our local climate. And if other states and then other countries begin to follow our lead, there is an opportunity for us to stop and, in the long run, reverse climate change and go back to what it was before what's now called the Anthropocene. We're really in a new geological era. A million years from now, geologists will dig through the strata and say, oh, here's where the Industrial Revolution started. This is the Anthropocene. This is when mankind modified the oceans, the atmospheres, and the Earth's solid surface in profound ways. So this climate change is an existential problem. It is a problem of our very existence. If we don't begin to mind our manners and take better care of the planet, there are going to be consequences, some of which we can forecast, some we can't.
Well, we have reached the end of our show. Thank you, Dr. Dickerson, for joining me and for all the work you are doing.
Oh, it was my pleasure. Thanks for inviting me. And tell your best students who are studying the sciences to come on over to College Park when they're finished at Howard Community College.
I'll be back next month with another guest and another sustainable topic. In the meantime, if you have ideas or comments, you can connect with me at rmarietta@howardcc.edu. You can listen to this and all of our other episodes at greendragonhcc.podbean.com. And you can also catch us on HCC TV and Howard Community College's YouTube page. Don't forget to share, like, comment, and let others know to join us and help us take care of our world, because every small step we take can have a great impact. Thank you.